Good morning. Great to be here again. I really love that picture. First, I have to make a technical setup. Nordic Data Science and Machine Learning Summit, my favorite time of the year. This is actually usually when I have some time to sit down and think a little bit. I spend all year working, and then I get to take a few days, a few weeks to sit down and start thinking about what's next, what's important. But I was standing here last year on this same stage, and I thought I would be nice to those of you that actually missed it and do a bit of repetition, on the things we took up. We talked a lot about last year about the unicorn of data science. We talked about diverse skill sets, ROI, and automation. And I just wanted to follow up a little bit on that, because what we see on the market is really that AI adaptation, and for us that actually work in the field, we know that AI can mean a lot of things. It can mean heuristic rules, can mean advanced algorithms, it can mean just fluffy sales pitch. But basically, we start seeing a larger adaptation of the general terms in companies. Although, on the other hand, you read papers and research that claim that a lot of the startups utilizing AI is not actually. So, state of the union is that we see a larger adaptation just across the board. I'm not sure if we see a good adaptation, however. But the term artificial intelligence has been around since approximately 1955. And we all know what's happening. We all know that everybody is speaking about it. And it should be more integrated into companies. I think that what we need to figure out now is data science and machine learning the new IT? We all know that the boom is happening because we have better algorithms. We all know that data availability is much better. And we know that computing power has exploded. But are we really good at utilizing it? So we need to talk about machine learning and data science from the point of view on skill sets and roles. We need to be more precise what it is we're talking about. Because if you compare it to IT, that's been around as a discipline much longer than data science, they are still struggling with this. If somebody says, I work within IT, then your parents and relatives will probably ask you if you can fix their laptop, even though you're a systems architect. And the same thing might be with data science. What are we meaning? What are we doing? And the same thing goes for machine learning. I think that we see somewhat of different mindsets. I have recruited a lot of people within the field. I have conducted, I think, close to 500 interviews with data scientists and machine learning engineers. I've hired people extremely skilled with good qualifications that fail to deliver. And I've hired people with basically no academic background that's been the absolute solid rock of my delivery machine. So how do we pinpoint what it is we need? What is a data scientist? And what are they doing? We know that we work with math. We know that we work with data, and we know that we work within the data science, software engineering field. And I mean, all of you have seen this Venn diagram, which is a nice way of presenting different skills and seeing this is the unicorn. But I think we need to be more clear in our projects. What skills are we looking for? We can call them data scientists, but we need to be even more specific. One of the kind of thought-provoking questions that some people get quite annoyed with is data science software engineering? I saw a very good talk, I think it was PyCon 2016, which had the very kind of nice title, Data Science is Software Engineering. I'm putting this question up here because I don't know. I honestly don't know. I know that there are major components in data science development that require really good software development skills. And I know if we don't utilize software engineering best practices, it will be extremely hard for us to reach production. We need to be better on defining these types of systems that we are delivering. So I thought a good way of walking through this would be to describe how we create ML systems. Because we can talk about algorithms all day long, even though I might not be the best one in this room to do it. But we need to understand in the context that we are delivering. And by doing that, I would like to just walk through how I create machine learning systems. Because at the end of the day, that's what we're doing, regardless if it's a simple notebook or if it's a full-fledged API system delivering millions of predictions per second. This is an extremely ugly picture, but this is actually AI generated. I was online on this AI robot, something for quotes, and this came up. And I thought this would be a very good basic for describing how we start. Because before we start working on these projects, we usually need to understand what it is we're trying to do. What do we want to accomplish? And I think that the main context, this is a two-parter, is that we want to be extremely clear with what we want to achieve. The type of systems I've seen that doesn't have this clarity and goes along in kind of this trial-error approach usually ends up with a very tangled infrastructure which is hard to scale. And the major part I see most people failing with is that we don't validate value early. If we're making predictions, if we're making assumptions, we need to have a methodology to actually validate that the things we are producing in a data science machine learning context for production needs to be value validated. And then, obviously, after you have some value validation, this is usually where the data scientist comes in early on. The first initial hypothesis, the notebooking, the kind of how do I do things? And this is even before we even start to think about a system. This is when we start just exploring, the exploratory part of data science. And then, when you actually have achieved a little bit, then it's time to put a little bit of pause of the algorithmic part. Then we need to start thinking about, so how am I going to design my system? How am I going to go from notebook and insight into a value delivery perspective? And this is not spending 6 months in a pre-study designing the full-fledged system. This is understanding how do I contextualize the insights, how do I work with the data, the algorithms, and then go to production continuously. But I think one key thing that people forget is before we even start with machine learning, we need to understand what we want to measure. Many of the projects I've seen in multiple companies start with the algorithm and then build a system around it. But it should be the other way around. And this, I think, is quite hard for people that loves data and algorithms to hear. But if we create a modular architecture, which makes it easy for us to change the core of the system, the algorithm, we start with validating value, and then iterations over iterations we improve. So the first phase of building your system is really creating the foundation. It is not about the algorithm, it's about the pipelining, the systems engineering, the software engineering part. If you have good pipelines, you will not build just one model. You will be able to improve your models over and over again. So lay a good foundation for your data scientists. And this is what I see over and over again. Data scientists are expected to be software engineers. I think that is a fundamental wrong, unless they actually are software engineers. They should focus on the algorithms. And engineers, and machine learning engineers, main objective is to make life easier for data scientists so they can work more on the data, the exploration, the algorithms. And for that, we need a good systems foundation. So it's really about not focusing on building a core foundational layer. It is about creating a delivery mechanism that goes from insights to production quite fast. Not the best system in the world, not the most scalable system in the world, but a system that we can incrementally improve. Not just from a data algorithmic perspective, but from a system perspective. And when you have achieved that first part, the piloting, it is really about you have a system foundation, your data scientists can work more with notebooks and insights, and then incrementally you can start delivering. Sprint after sprint after sprint after sprint. And that is where you see the massive growth, your low-hanging fruits, and where you really are getting the tap on the shoulder from the business side. So it's really about building this pyramid step by step, delivery by delivery. It is not about spending 6 to 12 months in building one system and then start delivering. We deliver immediately. Not the best delivery in the world, but as long as we can gain some value, we can get more funding and we can continue delivering. And I wanted to put this in context as well, because today, what we lack in data science is a lot of best practices on delivering. So if we utilize software development best practices for our data science projects and products, we will see a better gain. And these numbers are basically from state-of-the-art of DevOps. So if we utilize automated pipelining, automated build, automated testing, unit tests, all of those software development best practices, we will see a larger return on investments. And at the end of the day, that's what our stakeholders want to see as well. And then when we've passed these phases, when we have done all the kind of apple picking, low-hanging fruits, that's when things start getting interesting, especially from a data science perspective. This is where we start looking on the complex models. This is where every 0.1% counts. This is where we implement the most advanced models. Because things get tougher and tougher. There will be a slow start to get the system up, rapid growth, and then optimization and refinement over and over again. And I mean, it's really about putting it into the business perspective. It is about the ideation part for summary, the proof of concept, rapid deployment into production, and then mapping these phases into it. Because end of the day, we all want to be on the run and improve, and being able to go to the next project. We want to do more things. And if we don't deliver value, if people are just sitting around waiting for us to be done, then we will never get a new project. But as in all great stories, there are problems. Just like creating the paradigm of self-driving cars. Who should I hit? If you have to choose. Is it the grandma or the baby? Just as we have problems within machine learning and systems. If you are building a system without understanding what it is you're building, you will fail. I've seen people follow this methodology, but they didn't really understand what it was they were building, because this is not traditional software development. You're not building a static system. You are building a system that constantly moves and improves. You will have data drift. Your algorithms will be unable to detect patterns. Your systems and serving environments will see pressure that you didn't expect. When you're designing a system for machine learning, these are two separate processes. One is for building. It's extremely compute intense. It doesn't make sense to entangle them together. For computation, you can have one cluster or auto-scaling, but for serving, you just need a thin layer. Well, not for deep learning, but you get my point. So if you don't understand what it is you're building, you will still face scale issues. So it's not expected of you to read all this, but putting it into a context, there are dependencies, there are processes that you need to understand within data science and machine learning in order to create a system. When we talk about data science, in my point of view, which might be wrong, feel free to give some feedback, work mainly in model exploration. But today, most of the data scientists are all over the place, trying to implement new A/B testing, trying to be responsible for unit testing. These roles with that large area of responsibility are doomed to fail. A data scientist should work in model exploration because that's hard enough. The rest of the thing is software engineering, creating systems for scale. We need to make it easier for data scientists to make insights, need to make it easier for them to access data. And obviously, managing technical debt. Technical debt is not always a bad thing. And technical debt is the legacy you get as soon as you start writing code with dependencies. Technical debt can be a good thing if you want to get started rapidly and gain value. But if you don't start thinking about what it is you're building, what type of AI product it is, you will have a lot. And managing it is not a small thing. If you put it into context from a software developer perspective, the machine learning code is just a tiny, tiny little piece of the entire system. You have so many other dependencies that you need to think about. So if we say that data scientist needs to focus on the data, the insights, the algorithms, then we need to have extremely well-trained and good engineers to help them managing the complex infrastructure around it. Because what they are producing is usually a few lines of code. But that code takes a very long time to actually get to the real insight. So we need to be better on enabling data scientists. And obviously, this was about the algorithms and the IT tech part. But in my experience, you can build the best system in the world, but if you can't get anybody to use it, you have failed. And what I've struggled with extreme amounts of time the last few years is actually getting the usage out there. The big part is getting the business side to understand and trust the numbers. So when we give them a prediction, you should buy 50% less. And they say, there is no way we're going to do that. That's the hard part sometimes. So summarizing on my somewhat of a technical aspect of data science and machine learning for a few people, we need to make it easier for data scientists. We that are more technically enabled within this domain needs to create systems and processes for data scientists to work on the problems they are good at. We need to implement software development best practices, CI/CD, unit testing, all of the things that's kind of been hyped the last few years in software development. And we need to truly understand what it is we're developing, because the algorithms is just one part of it. The systems is how we get the value. And obviously, do no harm, do good. I always want to put this in the end, because I do think we have the powers at our hand to change society. We have the insights, we have the data, and we are in the projects that are going to be the next generations of companies out there. So we need to also treat this with respect and be role models for the rest of society, what we do with the data. And then I have a good message for all of you. AI-generated quote that came up. We are not parasitic. Thank you.